Hello everyone and welcome to the next instalment in the standard level exam questions. Today's question comes from the statistics and probability section of the syllabus. I've given it 2 out of 5 stars here. I don't think it's too tricky. If you know your stuff, you know your formulae, you should be fine. So a little bit more detail on what's in there. You can see here I have the detail from the syllabus on this particular section, 4.6. We're dealing with Venn diagrams, we're dealing with probability trees, we're dealing with some of the formula probability and particularly the conditional probability formula. So we dive into the problem. You can see section A is all about a probability tree, should be fairly straightforward. Section B deals with, again, just having to make your own tree here really. And then section C is the conditional probability. Let's go through these one by one and see how we get on. So here's A. Now notice it says copy and complete. It does tell you again, do not write on this page. In section B of the exams, you're expected to create your answers on line paper separately. Don't forget to do that. They genuinely will not mark anything you put here. It won't be sent to the examiner. So filling in the tree should be fairly straightforward. We remember simply that probabilities add to 1. So once I've already gone for the first white disk with a probability of 3 out of 7, so I'm along this branch here, I then ask myself, what if there's a probability of 2 out of 6 of it being white? Then there must be a probability of 4 out of 6 of it being red, simply because probabilities add to 1. We then go down the other side. We've got the red now as the first choice. That was probability of 4 out of 7. And so we just have to adjust what's going on here because these have been picked without replacement. So once that first red ball has gone, we're only left with 3 out of the remaining 6 being red. So we have 3 out of 6 there. And then, of course, again, probabilities here must add to 1. So our white is 3 out of 6. So those are going to be your first 3 marks for completing the probability tree. And then it says find the probability that 2 white balls are chosen. Again, if you understand probability trees, this really isn't too tricky. We're going to be going along this branch and then this branch to get white, then white. And we simply multiply these 2 probabilities, since we know the probability of 2 independent events happening is the product of their individual probabilities. This gives us 6 out of 42. And of course, whenever our answers are fractions, we should always simplify, leaving us with 1 out of 7. Now, you don't have to multiply through all the other branches of a probability tree, which you sometimes would do. We've simply got the one that we were required, and you might like to just form that as a fully correct answer using the probability notation. Probability of 2 white is 1 out of 7. That's it for section A. Pretty straightforward. I think so long as you remember to copy and complete the tree rather than write it on the question, there should be no difficulty here. On to section B. Bag B, now we've got a separate bag from bag A, contains 4 white, 3 red. So a little bit different here, the makeup of the probabilities. And we're told that when 2 balls are chosen at random without replacement from bag B, the probability they are both white is 2/7. So we don't need to do anything with bag B. We're just told that if we choose bag B, the probability of 2 whites will be 2/7. Next, a standard die is rolled. If a 1 or 2 is obtained, the balls are chosen from bag A, otherwise they're chosen from bag B. So there's a lot of info here, just a bit of an info dump. You've got to read through and decide what's important or not. But essentially what we've got is a dice deciding which bag we choose from, and then obviously choosing from that bag gives us 2 whites with a particular probability or not. So we're asked to find the probability the 2 balls are white. So we need a probability tree that divides off like this, and this I guess is choosing bag A, bag B, and then from the second branch we just simply need the probability of 2 white or not 2 white. So we don't have to worry if it's 1 white, 1 black, 2 black. We can just say not 2 white. So often in probability we just use a dash to signify the opposite or the complement event. So there we go, 2W with a dash. Now the probability of choosing bag A is, that's if I roll a 1 or a 2 on my normal 6-sided dice. So that's going to be 2/6 or 1/3. Therefore the probability of choosing bag B will be 4/6 or 2/3. Remember, we write our probabilities along the branches and the outcomes at the end of each branch. If I've chosen bag A, we've already seen from section A, the probability of getting 2 white balls is 1/7, and so the probability of not must be 6/7. And from earlier on in the question, we're told that it's 2/7 here and 5/7 it must be there. So you can see we're leaning heavily on that fact that probabilities of all the possible events add to 1. In this case, it's simply 2 whites or not 2 whites must add to 1. And then here we're just going to multiply through the branches to get the desired outcomes. Now you'll notice this time there's 2 ways of getting 2 white balls. We can go A and then 2 white, or we can go B and then 2 white. So we're going to need to work out both of these probabilities and add them. Some people like to remember the adage, you multiply across and you add down for a probability tree. It kind of helps us. So here we'll do 1/3 times 1/7, which is simply 1/21. And for the lower option, we're going to do 2/3 times 2/7. And this is going to give us 4/21. Now, altogether, that's going to tell us that the probability of 2 whites in this scenario is these two added together, so 5/21. So that's the probability of drawing 2 white balls in this whole scenario where we roll a dice first to decide which bag we're going to pull from. Next we come to section C, which deals with conditional probability. Now, the reason I know it's conditional is this word here. We are told that given. Now, probability is what value do we assign to the odds of something happening? But the information that we have affects that decision. So conditional probability deals with the fact that you've been given some condition and now we're asked to find the probability of something else. So the keyword given here is really important, and it tells me I'm dealing with a conditional probability question. These can be a little bit tricky, but if you identify clearly what the events are in question, you should be okay. So given that both balls are white, find the probability that they were chosen from bag A. So we're still in that scenario introduced in section B where we roll the dice. That determines which bag we choose from, and then we see if we can get 2 white balls. And we're given that both balls are white. So all I'm going to do here is use the conditional probability formula. I identified that from the syllabus earlier, and you can see it here. And it says probability of A given B. That's how we read that vertical line. So the probability of event A, given that event B has happened, is given by this formula. So let's be really clear about what our events are here. Event A is that we chose from bag B, because that's what we were asked to figure out. Find the probability that they were chosen from bag A, so the probability of A. Now it's a little bit tricky because we've already used A's and B's in this problem for the bags, but what we want here is event A to mean we chose from bag A. Event B is the outcome that they were both white, and we can find all the values for these from the previous sections. So being really clear about what events we're dealing with, and we're good to go. So now we can just substitute into the formula and say that the probability of A given B, so the probability that I have chosen from bag A given that I've got 2 white balls, is the probability of A and B. Now this takes a little bit of thinking about, but it's the probability that I chose from bag A and they were both white. Well, we've actually already figured this out. You can see here in the previous question, here's choosing from bag A, here's them both being white, and this is the value I'm after here, 1/21. So I can take that, substitute it into my formula. Then on the bottom, I have the probability of event B. Now event B is that they are both white. And again, we figured this out in the previous section. Here it is, probability of them both being white in this scenario is 5/21. So we go back to the formula and we can substitute that value in, 5/21. A little bit tricky to have fractions in fractions, but here we can see quite simply that we're just going to cancel through by this 21. So we're really multiplying the top and the bottom of the fraction by the same value, 21, and this is just going to simplify out nicely to our answer being 1/5. Now, some people do struggle a little bit conceptually with what this formula is and how it works. So perhaps a different way of explaining this or why it works would be to think about this outcome of getting 2 white balls in this scenario. Now, if you think of this as a Venn diagram, so this is just the region representing all the outcomes where both balls are white. Now, some of these are going to have come from bag A, and some of these are going to have come from bag B. What we have to do in this scenario is figure out what proportion came from each. So if 50-50, half of them came from bag A, half of them came from bag B, then the probability would be a half. But actually that's not the case, because if you look deeper into the probabilities, the probability that we chose bag A and got 2 white balls is 1 out of 21. And the probability when we choose bag B is 4 out of 21. So it's far more likely that we get 2 white balls if we chose bag B. So if we compare these two probabilities, 1 out of 21 and 4 out of 21, you can kind of think of this as saying if you ran this experiment 21 times, we would get 5 outcomes where they're both white. And of those 5, 1 of them would have come from bag A and 4 of them would have come from bag B. So comparing those proportions, we get our answer of probability of A given B being 1/5. I hope that makes a little bit more sense into how that formula works. Thanks for listening.